Hello, everyone. In part 2, we are going to discuss what would happen if your foundation is below your anchor, or we're looking at what I've defined as soil shear in the downhill case. So we've already discussed that we would like to avoid having the foundation significantly below the anchor if possible, but if it is significantly below the anchor, we're going to need to use steps. So what that would look like here is we'll take our anchor, take our foundation, and let's say this distance is around 3 meters. We're going to want to use steps like that. To both transfer those forces into the tiers and tower and try and eliminate what we had discussed before, which is the ramp wall dragging the anchor downhill. And the analogy we used was like sitting on a slide versus on stairs. But like I also mentioned, that creates a whole nother slew of issues. What we're worried about now is that the same thing happening in these steps shearing, the soil failing and shear, and forming that same slope that we're trying to avoid. So just like the previous check, we're going to find the capacity of the soil as tau and remember we're going to assume cohesionless and multiply by area, so we'll get the capacity of the soil to be the vertical forces times 10 feet. And we do need to do one quick thing before we just take the vertical forces from our previous calculations. We need to do that. We need to calculate the vertical forces as the weight of the soil steps and we'll calculate that on a case-by-case basis depending how we want to do these steps, plus transformed vertical load. And in order to find that transformed vertical load, what we're going to do is just look at that slope from the, if we want to be the most, if we want to sharpen the pencil as much as possible, as much as possible, we want to take the back of the anchor to the front of the foundation. We'll use the geometry of our abutment to calculate that angle. We'll call it psi. And along that slope of that line we drew, which will be our failure plane, we're going to have our vertical forces, and then we're going to have what we want to transform, which would be our forces normal to the soil. And our angle would be psi. We can calculate our transformed vertical forces as prime, and that will just be our vertical forces times cosine psi. And in this case, depending on engineering judgment, speaking with your DIC, we can either take our vertical force to be the weight of the soil steps plus the entire weight of the abutment, which would be incredibly conservative and probably never pass, or we can just do the weight of the ramp, which would be the most conservative. Now, this check isn't completely fleshed out because we're still figuring it out on our end. And this is a new thing for EIA bridges, but a general rule to follow is when making the steps is maintain between 2 to 1 and 3 to 1 slope when you are making these steps. So you can see if the abutment itself is even feasible here, 4 steps, because we want to make sure that total rise or that total run is to rise is going to be between 2 to 1 and 3 to 1 ratio. So like I said, 2 to 1, 2 to 1 would be our minimum, and 3 to 1 would be our maximum.